Hello friends, I welcome you in lecture number 12 on exponential distribution. In this lecture we will discuss one more example on exponential distribution. So let's start with this example. A toll booth experiences cars arriving at an average rate of 30 cars per hour. What is the probability that no car arrives in the next 3 minutes? So here we are given that at a particular toll booth 30 cars are arriving per hour. We are given this rate, average rate of cars per hour, and that is equal to 30. This means we are given this information that in 1 hour average number of cars arriving are 30. And using this information we have to find the probability that no car arrives in the next 3 minutes. So this problem can be done using exponential distribution, and we can do the same problem using Poisson distribution also. So in this lecture we will solve this problem using both the distributions, exponential as well as Poisson. So first we are solving the problem using exponential distribution, and whenever we are solving the problem using exponential distribution, we have to consider our random variable as time between events or time until some event occur. So let me write that first I am using exponential distribution. So here we are interested in the probability that no car arrives in the next 3 minutes. That is, in 3-minute interval no cars will arrive. Suppose this is the interval of 3 minutes, then we are interested in the probability that no cars in next 3 minutes, that is no cars in the interval of 3 minutes. So this is equivalent to this probability that time until the car arrival is greater than 3 minutes. If the time until the arrival of car is greater than 3 minutes, then we can say that there are no cars in the 3 minutes. Because if we want to use exponential distribution, we have to consider time as random variable. So we are converting this statement into the equivalent statement. The statement that no cars arrives in the 3-minute interval, that is equivalent to the statement that time until the car arrival is greater than 3 minutes. That means there are no cars in the 3-minute interval. So first we will define our random variable. We consider capital X equal to time until the car arrives, and this time we have to consider in the unit of minutes, in minutes, because we have to calculate the probability in 3 minutes. Now as we know, if we have exponential distribution, then our lambda is average number of units, average number of events per unit of time. For exponential distribution, parameter is lambda, and it is equal to average number of events per unit of time. Here we are talking about cars, so we are interested in the average number of car arrivals in or per minute, because our unit is minute. Here we have to calculate the probability that no car arrives in the next 3 minutes. Therefore we have taken capital X as time in minutes. So I will require the average number of car arrivals in 1 minute, and I am given that there are average 30 cars per hour, that is in 60 minutes they have given that average number of cars arriving are 30. So using this information we have to first calculate the average number of cars in 1 minute. So that we can do easily. Suppose I write in this way. Here I am writing minutes and here I am writing car arrivals. I am given that in 1 hour 30 cars are arriving, 1 hour that is 60 minutes. So we are given that in 60 minutes 30 cars are arriving and we are interested in the number of cars in 1 minute. So this is nothing but 30 into 1 divided by 60 and this is equal to 1 by 2, that is 0.5. So this 0.5 is the average number of car arrivals per minute and that is our lambda for exponential distribution. So we can write that lambda equal to average number of cars arriving in 1 minute or per minute, and that is equal to 0.5 that we have obtained using the given information that in 1 hour 30 cars are arriving. Therefore we can find the average number of cars arriving in 1 minute. So this is very important step. You have to write down the appropriate value of parameter and you have to remember this, that if we have exponential distribution then parameter lambda is average number of events per unit of time, and this unit you have to consider the unit which you are asked to calculate. Here we are asked to calculate the probability that no cars arrive in 3 minutes. Therefore we have taken random variable as time in minutes. Suppose we are asked to calculate the probability of no car arriving in 2 hours, then here instead of minutes we will consider time in hours. Suppose we are asked to calculate the probability that no car arrives in the next 5 seconds, then here we will consider our unit as seconds and accordingly lambda will be average number of events per unit of time. Now if we have lambda, then we can write down either CDF or PDF of exponential distribution. Suppose we want to use CDF, then we will write CDF of exponential random variable x, that we know the formula for CDF is 1 minus e raised to minus lambda x, and therefore fx becomes 1 minus e raised to minus 0.5 into x. Now once we have CDF we can calculate this probability. So now the required probability is that no car arrivals in the next 3 minutes. No car arrives in next 3 minutes. This we are asked to calculate, and as I have discussed that if the time until the car arrival is greater than 3 minutes, then no car will arrive in the 3 minute interval. So these two statements are equal, but this I have rewritten in the form of time because I want to use the definition of random variable capital X. We have defined capital X as time until the car arrives in minutes. So if time until the car arrives is greater than 3, that means there are no car arrivals in the interval of 3 minutes. So once we have written this, then this we can rewrite as this is nothing but probability that capital X is greater than 3 because time until car arrival is our random variable capital X, and this is equal to 1 minus probability that capital X is less than or equal to 3. We know that these two events are complementary events, therefore probability of this event equal to 1 minus complement of this event, and this is now value of CDF at 3. If you recall, definition of CDF is f of x equal to probability that x is less than or equal to small x. So here if we compare these two, then small x is 3, therefore I have written 3 here. And now what is f of x? F of x in this problem is 1 minus e raised to minus 0.5 into x. So here we put x equal to 3. We are interested in the value of CDF at x equal to 3. So here I will write minus 0.5 into 3, and if I take this negative sign inside the bracket, I will have e raised to 0.5 into 3, that is minus 1.5, and this is equal to e raised to minus 1.5. This you can find out using scientific calculator. It turns out to be 0.2231, that I have calculated somewhere here. E raised to minus 1.5 is 0.2231 using scientific calculator up to 4 decimal places. So we have solved this problem using exponential distribution, and whenever we are using exponential distribution, our random variable capital X is time until the event occur or time between the successive events, and lambda is average number of events per unit of time. And this is important. We must understand that these two statements are equivalent, that no car arrives in 3-minute interval, that is equivalent to the fact that time until the car arrival is greater than 3 minutes. Now we are doing this same problem using exponential using Poisson distribution. Okay, here they have not specified that which distribution we have to apply. So either you can apply Poisson distribution or you can use exponential distribution to solve the same problem. Now what is given? That we have to calculate the probability that no car arrives in the next 3 minutes. So for Poisson distribution, our random variable is the number of events in a given interval. Here we are interested in the number of car arrivals, that is capital X we will define as number of car arrivals in 3-minute interval or in 3 minutes. So here this interval is from this question itself. In Poisson distribution, we consider that interval in which we are asked to calculate probability. Here we are asked to calculate the probability of no car arrivals in 3-minute interval. Therefore, we will define capital X as number of car arrivals in 3-minute interval. And if you recall, for Poisson distribution, lambda is average number of events in the given interval. So here our lambda is average number of car arrivals in 3 minutes. Okay. Understand the difference between Poisson and exponential distribution. In exponential distribution, capital X is time until car arrival in minutes, and lambda was average number of cars per minute or average number of units per average number of events per unit of time. But for Poisson distribution, parameter lambda is average number of events in a given interval, and that interval we decide from the question and we define random variable in that sense. So for Poisson distribution, random variable is number of events in a given interval, and parameter lambda is average number of events in a given interval. Now we are not given average number of cars arriving in 3 minutes. We are given average number of cars arriving per hour, that is in 60 minutes. They are given that 30 cars are arriving. So we can calculate for 3 minutes easily. So this turns out to be 3 into 30 divided by 60, that is 3 by 2 or 1.5. This means average number of cars arriving in 3 minutes is lambda equal to 1.5. and in exponential distribution our lambda was average number of cars arriving per minute, and here lambda is 0.5. So understand the difference between the two. Here exponential distribution is continuous random variable, and here we are interested in the time until the car arrives, and here we are interested in the number of car arrivals in given interval. Now once we have lambda, we can write the probability mass function of Poisson distribution. The probability mass function of capital X is equal to probability that capital X equal to small x is e raised to minus lambda raised to x divided by x factorial, and here our random variable is discrete. Now we can put value of lambda. Probability that x equal to small x is e raised to minus 1.5 to the power x divided by x factorial, and x is 0, 1, 2, 3 and so on. So what is this? This is the probability of x car arrivals in 3-minute interval, and we are asked to calculate the probability of no car arrivals in 3-minute interval, and our x is number of car arrivals in 3-minute interval. So that means probability of x equal to 0. We have defined capital X equal to number of car arrivals in 3 minutes, and we are interested in the probability that no cars in 3 minutes. That means capital X is equal to 0. So we have to put x equal to 0 here in this formula. So we have e raised to minus 1.5 to the power 0 divided by 0 factorial. 0 factorial is 1. This is also 1, and we obtain e raised to minus 1.5, and this is equal to 0.2231 using scientific calculator. So here also we are getting the same answer as we have done in the exponential distribution. So this is interesting problem. We have done the same problem using exponential as well as Poisson distribution, and if they have not specified that do this problem using particular distribution, then you can use either exponential or Poisson distribution, whichever is comfortable to you. But if they specify that you have to use exponential or Poisson distribution, then you have to use specified distribution. So what we have understood here is that if we are interested in the probability of no events in some interval, here we are having 3-minute interval. Probability of no events in 3-minute interval, that means time for that event is greater than 3, and for this we have used exponential distribution. And if we are interested in the use of Poisson distribution, then if we consider capital X equal to number of events in 3-minute interval, then this is equal to probability that capital X equal to 0, and here we will use Poisson distribution, here we will use exponential distribution. So I hope I am able to explain this problem, and we stop here. We will continue with this series in upcoming lectures. Thanks for watching.